When you're ready, you hear that noise, and look around for that first marker.
What we're looking at is whether or not changes in navigation may represent the very, very, very onset of Alzheimer's disease. And if that is the case, and it's still work in progress, that's, dare I say it, quite important, because it will be good for the field to get a feel for when this condition starts. Because the earlier we can diagnose the condition, the earlier we can apply medications that may help slow progression to dementia. The way Alzheimer's affects navigation is that it damages the brain cells, the neurons within the brain's temporal lobe, which essentially is one of the main parts of the brain controlling our navigation. The traditional way we test people's thinking and memory is via pen and paper tests. Problem with pen and paper tests, you can't really test someone's navigation with that. VR then turned up as a commercial tool about 8-10 years ago, but mainly for games playing. But the whole beauty of VR is that you can create an environment and you can navigate within a simulated environment. So it allowed people like myself access to a tool in which we could test people's navigation, creating a simulated environment, a virtual environment within which they'd navigate, and see whether or not they were making errors on navigation tests. We could also then compare their performance with how they may perform on your kind of standard memory sort of pen and paper tests.
Quite comfortable. When you're ready, just press that big green play button to start. So just have a look around, get used to the environment. So just walk towards marker 1, comfortable pace. So we're trying to reflect people's day-to-day spatial navigation and their ability to return back to a position where they were. So what you saw there was Patricia starting in one position, moving to a second, a third, and then trying to make her way back to number 1.
We hypothesized that people with early Alzheimer's would be very affected on our VR test of navigation, and we also went on to hypothesize that actually people would have problems with navigation at the very beginning of Alzheimer's, even before they had symptoms, way before they had dementia, and also before they had any other problems like problems on memory testing. And that's exactly what we found, and this is what we've published over a few years now. Augmented reality, AR, is much simpler than VR. And so I kind of figured, well, if we could create an AR version of our VR task in which we might sort of work out, see whether or not people can work out how they're navigating around, particularly how they're turning in angles, but we don't need a full VR kit. We just have like a sort of simulated virtual object where we use our AR in the real world, and we're asking them maybe to turn around, then that's really short. It's not risky because they can see the real world around them, and it doesn't need loads of staff to supervise. It could be done in theory really quickly. So that's the idea of the AR. We haven't done it yet. It is very much work in progress, but we are funded by the NHS to try to develop these new tests, and hopefully in a few years' time we'll have it.